Um, yeah, so hi, my name's Martin. I'm a fourth year mechanical engineering student here at the U of A. Um, I am I have been working in the lab since September. This is my second co-op term of my degree. So over my 7-ish, 8 months, I've been mainly working on the PLS sheep pregnancy project, mainly doing work for blood collection. So we were trying to make a blood collection device so we could easily collect blood from the sheep without having to call a vet out. So that's this little fun device over here. Um, we didn't have too much success with that, unfortunately. Um, we also tried to print microneedles. So that's this little tray down here. So this little one is only about like 3 millimeters high, if that gives you a good perspective. And basically we printed this to see how small we could get with getting a hollow channel in the middle so we could extract blood. We never got to try that one out. We did get to try this device out. So yeah, that's basically what I've been doing for the last little bit at the lab. And then for my present today, I am mainly going to talk about the physics of climbing, mostly about some of the stuff with anchors and then falling, because it is climbing season again with summer coming around. So a little intro to climbing for anybody who doesn't know. There's many different types of climbing. So there's bouldering. It's this picture in the middle here. It's basically a 4.5 meter tall wall that you go and climb up, and you don't need a harness or anything. You kind of just go, and then there's a wonderful mat that will catch you. There's also top roping. So you're basically always tied in at an anchor at the top. So if you fall, you're caught by a rope right away. And then another one is lead or sport climbing. And that's this picture over here. And basically you clip as you're going up the wall. So there's points where you're climbing above your anchor point. So if you fall, you're actually falling quite a bit at times. And that can be very fun. There's also many different types of climbing. There's multi-pitch, traditional ice climbing, and via ferrata. But those are a bit less popular. So some of the equipment usually used if you're doing sport or top rope climbing, rope, quick draws, some slings, a belay device. So you can use a gree or ATC. They both work on friction to keep the rope from slipping, which is kind of cool that just a little bit of friction can hold a whole person when they fall. And then a harness and some shoes and a carabiner. So just a recommendation, if you're buying any climbing equipment, just make sure you're getting it from a UIAA certified brand. They're an international mountaineering association that basically certifies all climbing gear in a third-party way. So you know it's all safe. It's going to catch you if you fall. You hopefully won't die. And all climbing gear is rated in kilonewtons. So that's about 102 kilograms of weight with Earth's gravity. And I couldn't really find a way to put that in perspective, but Airbus A320 plane uses about 120 kilonewtons of thrust to take off, which is quite a bit. And yeah, also, if you have any climbing gear, all fabric climbing gear has an expiration, usually about 10 years before it starts to wear out and loses its weight-bearing capacity. So yeah, when you're climbing, usually outdoors, this is for sport climbing here, there's anchors, they're drilled into the rocks. So they'll be kind of dotted around the climbing course all the way up the route. And the strength of them is very much dependent on the age, how much wear they have, the types they are, and the rockets installed into. Usually they try to make them so they can withstand more than 14.5 kilonewtons pulling them straight out, and then more than 2.5 kilonewtons going down. Usually you won't, like a big fall is usually about 9 kilonewtons, so you should be pretty safe. At the top of a climb, you'll see something like this. And basically, this allows you to go down. It's just a double anchor. It's also how you set up a top rope anchor, which is very fun. So yeah, as you go up, to attach yourself to the wall anchors as you go up the route, you actually use, we call these quick draws. So they're just 2 carabiners connected with a little piece of fabric. So most quick draws are rated at 22 kilonewtons. This is more than enough to hold you, even if you take a big fall. The only thing that you don't want to do with quick draws is back clip. So back clipping is basically when you put the rope in backwards, so like this. And the cool thing you can do when you back clip is if you fall, you can potentially unclip yourself from the wall, which is not ideal. And that is why there's a skull and crossbone on this picture. But I find it very cool that if you just put the rope in the wrong way, geometry will do a fun thing and just unclip itself. The other anchor you will do is a top rope anchor. So basically, instead of sport climbing where you're clipping all the way up, you just set up one anchor at the top. You're always tied in. So these are 2 different ways you can make a top rope anchor. So basically you put some carabiners, a sling. The knot in the rope will actually decrease its capacity by 50%. This is due to tight bends causing the fabric to stretch in some places and compress in others, and it creates stress concentrations. And these stress concentrations are what will weaken the sling and the rope. And that's why it's tied in twice to the top anchors, so that you get double the carrying capacity and then it's halved. So you still get the right amount of capacity you need. So if you need to calculate the forces acting on each part of the sling, it's actually quite easy. You just do this free body diagram down here, and then you just sum all the forces to 0. So we can do that. And then you kind of assume the forces are split equally between both strands of the anchor. And then once you sum it up, you get this very fun equation down here. So it gives you the force for each strand. So if, let's say you have an 80 kilogram climber, the strands on the top rope anchor are spread out by 45 degrees. Then you're putting about 554 kilonewtons or 554 newtons on each strand, which usually these slings are rated to 22 kilonewtons. So as you can see, it's very much overkill for how they make these, but it's better to be safe than sorry. A little tip, if you're ever out making a top rope anchor, use a girth hitch knot, because they're so much easier to untie than a regular knot. See, because if you fall or you're putting weight on a regular knot, it will tighten up. A girth hitch knot will also tighten up, but it will also release once you release the weight, which is really nice. And one of the worst parts about climbing and why you anchor yourself so much is because you don't want to fall. And if you do fall, you want to be caught. So there's actually some fun stuff with falling, and that's fall factor. So basically it's a way to tell how hard your fall is going to be. So if you have a fall factor of 1 or less, it will be a light fall, and it will be, I don't know if you could call it pleasant, but it will be a lot better than being whipped into the wall or a very just falling onto concrete, I guess. If you have a fall of 2, that's actually pretty hard. That's the worst you can do. And yeah, you want to avoid that. So basically what fall factor is you're taking the amount of rope in the system. So in this example, there's 10 meters of rope. And then you take how far they are falling. So they're falling 4 meters. You divide the 4 meters by the amount of rope in the system, and that's how you get your fall factor. The reason that fall factor matters is because rope is actually an elastic, and when you're doing calculations, you can consider it a spring. It is a very stiff spring, but it cushions your fall. So the more rope you have in the system, the softer the fall will be. A fun thing is sometimes routes are not straight. They're very all over the place like this. And when that happens, the friction force at each anchor that the rope is going through can actually be so big that it reduces your length of functional rope, because the friction force will stop that piece of rope from actually stretching when you need it. So this can actually increase your fall factor and is something you should look out for when climbing. So to calculate the impact force on the anchor, you actually have to do conservation of energy. So you take the potential energy of the climber, which is mass times gravity times the height, and then you take the potential energy of the rope, because you consider the rope as a spring. So that's this wonderful formula here. And then you consider them to be equal. And then you also have to use the formula force equals mass times gravity, which also equals the spring constant times how much it stretches. And you basically sum it up and you get this wonderful formula down here, which calculates the total force at the anchor when someone falls. And then to calculate K, companies will not give you that. So you kind of have to calculate this yourself. What they do give you is the maximum force rating for the rope. So they'll say like this rope is rated to like 8.6 kilonewtons, something like that. And then the maximum stretch of the rope, which usually they will say at that max force, it has 33% of stretch, or something like that. So I actually have, oh, yes. So that's the force on the anchor. Define the individual forces for the climber and belayer. So the climber is the one person that would be falling. The belayer is the person on the ground who will catch them with the rope. You actually have to take friction forces into account on your top anchor. So one of the climbing companies, Pretzel, estimates that there's a 50 to 66% of friction created by the top anchor. So basically, to calculate the force on the belayer, you take the force from the anchor, you times it by the friction percent, and you get the force on the climber. And then, because all the forces in the system need to equal 0, you can use that to find the forces on the belayer. So you take the total force, which is the force on the anchor, you minus the force from the climber, you get the force that acts on the belayer. So I actually have an example here. So basically, this was a test done by a company, and I can actually show you it. because they tested this with real people, which is fun. See, it's a nice gentle fall because it's only a fall factor of 0.3. So to actually do all the calculations for how much force was acting on them, I looked up the specifications on the rope. We have this for the spring constant. The mass of the climber was 80 kilograms. They fell 2 meters. And then that's the gravity constant. We plug it into the formula. So there's about 4.3 kilonewtons on the anchor. The climber experienced 2.5 kilonewtons, which is about like 250 kilograms pulling on you. And then the belayer experienced 1.7, which is a little under 200 kilograms of weight pulling you. So a nice soft fall. Yeah, and then that's all. So anybody has any questions?
Thanks, Martin. Very nice presentation and quite interesting. So yeah, probably